We're now going to talk about the discriminant. And the discriminant can tell us what type of method to use to solve it. So we'll talk about that in just a minute. But remember that there were 4 cases in our earlier example. We had 2 rational solutions. We had 2 radical solutions with the square root still left in it because it didn't simplify completely. We had 1 rational solution, and we had 2 complex solutions. And these all revolved around that b squared minus 4ac is what determined all of this. And so we're going to talk about that. If b squared minus 4ac is a positive perfect square, then we get the 2 rational solutions. If it's a positive number that's not a perfect square, then we'll get 2 radical answers because we won't be able to get rid of the radical completely. If it's 0, and we're talking about specifically the radicand here, if it's a 0, then we get 1 rational answer, and if it's negative of any form, we end up with complex because we have a negative underneath the square root. So this b squared minus 4ac is the most important piece, and it's called the discriminant because it helps us discriminate. And so sometimes it's very helpful to figure out what your discriminant is before you even start the problem. So we're going to look at a few examples of this. So remember that on all of these we're looking for b squared minus 4ac. So suppose we have x squared minus 5x plus 3. So our first step, a equals 1, b equals minus 5, and c equals 3. So we plug this in, and we get minus 5 squared minus 4 times 1 times 3. Well, this is 25 minus 12, which is 13. 13 is positive. It's not a perfect square, and that means that we will end up with 2 radical answers when we finish solving this. Likewise, if we have 4n squared plus 12n plus 9 equals 0, there should have been an equals on that. A is 4, b is 12, c is 9. So we plug this in, and we get 12 squared minus 4 times 9, which is 144 minus 144, which is 0. So this means this is a perfect square trinomial, and we have 1 rational answer. And so by using the discriminant, we can tell the difference between them, and we can then say, oh, that means that we could factor it, that means we should use the quadratic formula, that means we should use the square root property, and so on and so forth. It can tell us our method. However, the hardest part of the quadratic formula is the b squared minus 4ac. Once you've found the discriminant, you might as well finish using the formula. So here's my rules for figuring out how to solve a quadratic. First, do what you're told. If a test question says, solve using the quadratic formula, then I want to see your work for the quadratic formula. That's what you're supposed to be doing. Then, we're going to look to see, can we use the square root property? Remember, the square root property is something being squared equals a number. And if it is, then solve it using the perfect square the square root property. Second, can we see it factor? If we can look at it and see the factors, then we might as well factor. And finally, if you don't see it factor and you know you can't use the square root property, then use the quadratic formula right from the get-go. It'll still find your answer from the others, and it'll get there. Notice, though, that completing the square is not part of our list, because completing the square falls squarely under the quadratic formula.